Hey everybody, this is Garrett with Earth and Time, and today I'm in beautiful St. George, Utah, in the southwestern corner of this state, where I want to come talk to you about this black hill that's behind me and something very unique that happened here and something we don't see very often in geography or in the geologic record, and that is we have two interesting things going on here. One, these are old lava rivers, which is really neat, so flows of lava that came through old riverbeds, and we'll take a look at some of those. But more importantly, what they call this is inverted topography. So generally with geology, if we use my hand, we think about the lowest, we'll say my fingers or the geology here layer, the geology layers. We think of the layer at the bottom being the oldest and the one on top being the youngest. Just like if you were going to make a cake, you stack the first cake, a layered cake, you put the first layer, second, third, fourth, you stack them in order from the first to the last. Geology works much the same way. We call this the law of superposition. However, in this case, the tallest parts, the things on top behind me and on the black hill there where you can see the D on it, actually, those are the oldest features on top, and they get younger as you go down. So really interesting geologic story known as inverted topography that was set up by these lava rivers that were coming through here. So with that being said, let's learn a little bit more about that. Let's get to it. I'm actually sitting on what's known as Sugarloaf Hill. So if I pan off to the right here, they call this Sugarloaf Hill, and this is actually a park they call Pioneer Park. So there's an old Pioneer house up here. At some point I'll come and do an episode on this as well. And there's an area known as the Narrows, our little slot canyons you can hike into this Navajo sandstone. So this is the same stuff that starts making up what we think about in Zion National Park. What I want to show you all is across the way from me are these series of black terraces. So we have things called mesas here. Mesa means table in the Spanish language, and these end up being these big flat tops. What's interesting about this set of mesas over here is they actually don't work the same way as normal geology. Normal geology says, if I look down below, the stuff that's lower is older than the stuff on top. So where I'm standing right now was deposited after the stuff down there. That had to come first, just like I was explaining with the cake. And then we know that things get younger as we come up the geologic section, all the way younger still once we get up here. However, when I look across the way, I see these black ridges coming through, and there's one up high here that's actually got just above the D, and then there's another ridge down below with some houses on it down there, and I think there's even another little ridge that comes out further down that direction. And what these are old lava flows. So there's a series of volcanoes that were erupting to the north of us, associated with, there's a little mountain peak coming over there, that's Pine Valley Mountain. There's a lot of volcanics that were popping off here tens of millions of years ago, and even up to tens of thousands of years ago, creating these lava flows. And at the time, the surface was about where I'm at today. So you can picture that all this in between myself here on top of the sandstone going across the valley, there's beautiful downtown St. George, over to the other side, that actually gives you an idea about the elevation during that time. So before all this erosion took place, those upper lava flows were deposited, and those are around 2.3 million years old on top, or around 2 million years old on top. And then there's another ledge with some volcanic features here that's much younger than that, as in like tens of thousands of years old, that come through here. So different than what we think about typical geology, you actually have older units above younger units, and that's all set up by this idea that these lava flows were lava rivers were following old channel deposits, and we can actually look at those in a couple spots, and I'll go take you to one of those, maybe two of them, so you can actually see what that looked like, where these rivers were coming through and moving along, going from north over here, flowing down this direction, going towards the south in that direction. So we refer to this in geology as inverted topography, and there's not very many places I know where you can come see this relationship, where you have the older rocks above the younger rocks like you see here. I'll go ahead and sketch what that could look like through time to give you kind of an image of what you would think about a cross section through here would look like. So in other words, you had this first valley that was developed, and you have this first lava flow about 2 million years old on top, then another valley erodes adjacent to that and allows this other lava flow to come flow past it, setting up younger rocks below the older ones. So let me go ahead and draw that for you now. So here's my trusty whiteboard that I like to draw on here. So I always like to say, to the whiteboard. So let's talk a little bit more about this idea of the inverted topography and what these lava rivers would look like through time. So what I've sketched here is a quick basic block diagram. This is representing the Earth. This represents a river coming down through it sometime. We'll call this time 1. And so initially you had the land, you had a nice river flowing through, and then you had a series of volcanoes that started erupting up dip from where the river was. And what ends up happening is these volcanoes started erupting, the flows would come down and replace the water with lava. So that what was once a regular river then becomes a lava river. Now through time, this landscape's going to continue to erode, and say this is our lava flow from 2 million years ago, and the volcanoes quit erupting, and you have the land start to erode around the original volcano. So this ends up becoming a mesa and sitting higher than the other land around it. And with that, rivers can then reestablish and start flowing through again. And a lot of times they're going to flow through a similar path. So the original river was coming through here. It can't flow down that channel anymore because it's all been solidified by basalt. So now it steps over and it starts flowing adjacent to that. Now, this was 2 million years ago, and then about 1 million years ago, we ended up having another series of volcanoes erupting, which again sent lava rivers and lava flows down these already established channels. And so now we had another lava flow coming down through and setting up along this channel. So another lava river comes through this area. And then we fast forward again, and through erosion, we have now set up the higher terrace that we saw in the distance that had the D on it. We have the lower terrace, and so I put a time 1 for the first time, a second time for the second time, which is actually younger and below the first terrace, and then you come down into the actual St. George Basin or Valley, and that's time 3, right? So this is younger still, the stuff in the rivers that be deposited down here. So this gives you this idea about this inverted topography where we go from older on top, younger, and younger still. Whereas I explained before, generally in geology it goes the other way around. So this is a quick sketch to hopefully help you understand this concept of inverted topography and what we're going to be looking at for the rest of today. Now that I've sketched that out and hopefully have an idea how these were set up through time and a little bit about the topography, let's go ahead and take a look at some of these road cuts where we can actually see these paleo channels of lava, these paleo old lava rivers that are still preserved, cutting down into some of the stratigraphy and road cuts around St. George, as well as let's see if we can get up close and look at some of this basalt so we can see what it actually looks like, and we can talk a little bit more about some of the volcanoes in this area. In fact, what I'll do is I'm going to actually link my video on Snow Canyon State Park, which is just north of here, about 20 minutes or so, and a bunch of the volcanic flows actually go through that park, and I talk about some of the volcanoes. I actually go visit one of the cinder cones or the actual volcano calderas where these flows were coming out of, so we can take a look at that on my video up here. So with that being said, let's keep rolling and let's go check out what some of these road cuts look like and what some of these paleo lava river valleys look like. Here's from a slightly different vantage point where we can see those lava flows again, and I need to make one correction. The highest lava flow, so the highest mesa there, is about 2.3 million years old, that lava flow, and the one that the houses are on down below, and there's actually an old airport on it and buildings, that one's right around 1 million years old. I believe I said 100,000 or hundreds of thousands before, but it's actually 1 million years old. Just to give you an idea, again, about 2 million on top, and the lower flow is about 1 million. So that's that inverted topography idea. And as I turn to the other direction towards the east, there's actually another one of these mesas here that is another basalt flow that I believe is in between the two. So I think this may be like 1.2 million years old or something like that, but you'll see houses built on top of it out there in the distance. So it's another one of these flows that flowed out, and we don't know where they eventually terminated because everything's been eroded as you go down to the south. As I was heading down the road, what's known as Red Hill Parkway, from the last stop where we got to see those volcanic flows on top of the mesas, I wanted to stop and just show you this amazing scenery and also point out some more of the volcanic features here. What we see right in front of us, all the red rock here, is known as the Navajo sandstone here in Utah. They also call it the Aztec sandstone in Nevada, or they call it the Nugget Formation or Nugget Sandstone in Colorado. So it goes by many names, but it's basically the formation that makes up Zion National Park, which many people are familiar with. But on top of that, you can see these volcanic flows. You can see this little butte there made up of volcanics. You can see another mesa, some of these other flows that were coming through these basically old lava channels. So old channels that ran from up here, probably at Pine Valley Mountain, which is that big mountain we see there, which is a big volcanic feature called a laccolith, and I'll do a video on some other time or some other day. But these volcanic features are ringing around that, and then the flows would have come off this higher topography down towards the basin here. Just thought this was a really nice spot to take a look at, and you can see the extent of the volcanic fields behind me. All that black rock in the distance are all these volcanic flows, or basically would have been these lava rivers coming down from up to the north towards Pine Valley Mountain, down towards the St. George area back between 1 and 2 million years ago. All right, so now I've moved north of the main mesa area, and I'm along what's known as Snow Canyon Parkway. And what I want to show is you can actually see the shape of this paleo channel. This lava river was coming down, and so you can see how it's got this concave type shape. You have the sandstone and mudstones below, and you'll notice they're kind of really light colored compared to the other sands and sandstone and mudstones around. And that's because when this hot lava came through, it basically baked it. And this is actually a diagenetic zone. So these are actually slightly metamorphosed, is what we call it. And you can see where the lava that makes up all that black up there came right down through one of these old channels. I bet if we went and dug around in here, we'd probably find some stream gravels at the base of this, because this would have come through that old riverbed. But you can see it's a pretty good sized river, you know, so you can see some cars driving by for scale. So what is it across here? Maybe a couple 100 feet or so, and maybe about 10 to 12 feet tall. If we kind of take a look at how tall that could be up there. But this really gives you an idea looking at one of these lava flows. In fact, this is actually the lava flow that goes down and I believe becomes part of that lower bench, or that million-year-old lava flow, or that lava mesa that we saw. So this is the upstream portion of that same flow. Pretty cool to see in person. What I'm going to do is I'm turning around from here. Let me turn 180 degrees. And so that river, that flow would have come right through here. You'll see there's some kind of, looks like oil or gas thing going on here. And you can actually see the mesas off in the distance again. So the older flows are on top, the 2 million year old ones, and the million-year old ones are down below, which line up perfectly with where we're at now. So this flow would have continued on to those lower mesas. I'm going to try to find a way to get up into those areas so we can take a closer look at what some of the basalts actually look like. I made it to the other side of the city here, and you can see where I was standing before, over on those red rocks over there, looking here at these two volcanic flows. Now I'm standing on top of the lower one right now, and we'll go take a closer look at that. Unfortunately, the higher one's up there, and I'm not going to get a chance to get up to that one today. However, you can get a nice view of where that's at in relation to where I'm at here. So it's, well, you can see it's probably a good 80 feet up there or so, maybe 100 feet up to the top one, and that's that older flow. Let's go take a look at this younger flow, the million-year-old flow, and see what that looks like, and see if we can look at some of the geometries and what's happening immediately underneath these flows. I walked down the hill, I don't know, 100 feet, a couple 100 feet, and you can see I'm parallel now to the flow here going towards the north, and if I turn around this side towards the southern direction. So I'm going to cross over and we'll get a closer look at this flow. First of all, here I am for scale. You can see the lava flow that was going down this channel. And actually at this point it's pretty brecciated, which is interesting. And I'm not sure what's actually happening in this area that it is so brecciated. So usually brecciation happens because of reworking, and that may actually be what's happening here. Some of the lava flows reworked itself as it was going down. So maybe we're in this lower section that got really reworked, and then we'll see the more constant flows or consistent flows on top. Let's go down and test that hypothesis down around the corner. But before I do that, let's take a close look at even this brecciated lava flow, this basalt flow. And one thing you can see pretty quickly is what we call the vesicles, or the air holes from the lava flowing down. You'll see it's all jumbled. You can see a nice big piece in there of this basalt flow. It looks like this area has been slightly altered, and I'm wondering if this is that basal section. Remember when I said that the basal section of the lava flow is probably coming across some old channel gravels or some old channel, and it's actually changing the color of the rock. And we can really see that here where it's much lighter on the bottom, whereas everywhere else, if I look around, all the rock is generally red. However, here it's this light tan color to, of course, this blackish to blackish red that is the basalt. So this basalt was flowing through these channels and basically cooking these gravels. In fact, this is a nice view of some of those gravels right here, and we can see some of those baked stream gravels here. So this would be what we call diagenetic alteration. You can really see that in here. So this would have been the old stream deposits. Pretty cool to see. And here's one more look at those stream deposits that we can see in here. That is pretty awesome. Don't get to see that too often. And oh, they break a piece off here. And see what all we can see here. We can actually see clasts of other basalts, it looks like, and a lot of fine sand. It looks like these things were also semi-rounded. Again, telling us that we were in a stream type deposit where this lava flow came through and replaced. Now I'm walking down the road, and we can see this lower bed that was the altered white river deposits, and then this nice massive basalt flow or lava flow. So this is exactly what I was hoping to see, is that this lower section is this kind of messy, brecciated, altered stuff, and then up above you have this nice consistent flow going over. Now, what I don't know, and maybe somebody who knows more about the geology here, I don't know how many flows this is. This may just be one single flow that came down through here, or there may have been kind of a preemptive flow in this lower section where we saw all that brecciated stuff, and then this other flow came on top. I'm actually not sure. One of the things that looks really interesting, are there possibly pillow basalts in this? Let's go take a closer look. What I'm looking at is a semicircular shape of the basalt. So we see this a lot when volcanoes erupt and the lava flows into water and is quickly quelched, and it creates almost what they call a pillow shape or the semi-rounded shape. And I see a couple features like this in this layer. In fact, we can see another one right through there. So this tells me that the lava was coming in and it was hitting a pool of water of some kind of depth to quelch it. In other words, to actually get it to form almost this pillow type look to it. That's really cool and something I've never noticed before. But again, more evidence as a geologist, it's more evidence that this was flowing down some kind of waterway, and these would have been lava, literally lava rivers coming through, replacing the water with all this lava, which later becomes basalt. That is so incredibly cool. I so love geology, and I love trying to figure out these stories. As I can tell, other geologists have worked on this. Geologists will come take these samples out of the rock, and they'll run different analyses. They can do dating of them. They can look at them underneath a microscope. They can actually look at the crystal formation of the iron in the basalt. So basalt has a lot of iron in it, and they can look and see how it's oriented. And why that's important is iron is naturally magnetic, and it'll naturally align itself towards the North Pole. So it gives us an idea about the direction of flow and also the direction of where north was at this time. So they call it paleomagnetism, and there's a whole study around that where we can put together how the earth has changed through time by looking at how the orientations of iron within things like volcanic rocks like this basalt have changed. Really interesting science. Okay, from here I'm going to head down towards the end of this flow and see what we can see down on that side. As I'm walking up the hill, you'll probably hear me go wee, wee, trying to catch my breath because I'm at a much higher elevation than in Texas. And I'm hiking up a steep hill. But with that, I want you to keep in mind that picture I showed earlier of how this inverted topography forms, and looking for those clues in these rocks to find out, is that what we're actually seeing? And everything's pointing to yes. Indeed, these are lava rivers following actual riverbeds, replacing the water with lava, becoming solidified, which means the next time water comes through, it's actually got to change its orientation and how it's going to flow, which means you can actually put another one of these lava flows next to it, like we saw in that picture. Woo! It's no joke hiking up this hill. All right, let's go ahead and head on to the far end of this mesa. I drove up the hill a little ways where there's a little bit of a paved road up here, and you can actually get closer to this older basaltic flow, and it looks very similar to what we saw in the one down below. Now, one thing I will point out, and it's a historical piece of information, is there's actually a little dirt road up here. So there's something called the St. George Temple, which we can't quite see from here, but it sits down in this area. They used the lava flow, they actually quarried the basalt and used it as the foundation for the St. George LDS or Mormon temple here. And this is part of that temple road temple quarry road where they could go up and get the material and then they bring it down here. I moved down the hill some more, down towards the south, and you can still see the lava flows here. Where we were looking at those other lava flows, it's about 1.5 miles, maybe a mile that direction. We can still see the stunning scenery here. If you've never been to Utah, especially St. George, Utah, it's pretty amazing. What I want to show though is I mentioned the St. George Temple, and you can see the temple there. And when the early pioneers first came here, it was very muddy here. So what they did is they actually used the basalts that we can see here. They carved them out, made blocks, and actually it's these basalts that are underlying LDS temple that you can see there, the white building out there. And pretty interesting story. It was a bunch of swampland because you have the Virgin River coming down through and cutting down through the topography, and you had all these wetlands in this area, so they had to find a way to create a foundation. And so they used the lava from this hill, and they actually have a quarry and what's called a quarry hike or quarry trail you can actually go on and actually go see where they got the lava out for the LDS temple here. All right, so I was on the far side of the hill over there, so that's the upper flow you can see, and I'm actually standing down on the lower flow, and what you'll see, there's actually a lot of gravel on top of here. They actually look like they're clearing this off, and I'm wondering if they're going to build some houses in this area. But this is the end of that lower flow, and as we look down to the south, you can't see any more of this inverted topography or any more of these lava flows or lava rivers. Really cool checking this all out. Thank you so much for going with me. I hope you learned something. I learned a lot. This idea of touring, this idea of an inverted topography, the idea that what we're looking at off in the distance there, the stuff on top is actually older than the stuff down lower, is a very different concept for a lot of geoscientists, because so often we work the other way around. Now, with that, we understand why that's the case. That's one of the other beauties of geology and understanding the principles of geology is I know that the oldest stuff should be at the bottom, youngest stuff should be on top. So why could that happen? Why would I see something different here? And then much like Sherlock Holmes or a forensic scientist, like CSI for the Earth, I can go back through and put together the story. Okay, this was an old channel up here, and the lava flow came through, then the stuff eroded around it, and then another lava flow came down a much younger channel that formed after a lot of erosion took place. So the older stuff's on top because it's also more resistant and less erodible, like we talked about when I did the drawing earlier, than the stuff around it. And so we can get this inverted topography. I want to say thank you all for joining me today. Please leave comments down below. I really enjoy doing these adventures, finding some areas that I can hopefully teach you all something new, make some new observations, learn something as well. If you all enjoyed this, you all know what to do at this point. With that being said, everybody take care, and we'll see you on the next adventure. And I like this perspective a lot of volcanoes and just showing the flows.